Hello guys and welcome back to the show. I've been using Apache Kafka for a while now, so today I thought I should share with you a bit of what I know about Kafka so that if you are just starting up with Kafka, it will be easier for you to get a high level understanding of what Kafka is and how it is used. So let's get started. The question is, what is Apache Kafka? Apache Kafka is a distributed streaming platform for ingesting, storing, and processing streams of data. And what this allows us to do is to scale and handle lots of requests with minimum downtime. We mostly use Apache Kafka to facilitate communication between systems. And when I say systems, I mean databases, microservices, or anything that can read and write over a network. Someone might ask, why do we use Apache Kafka as a means of communication between systems? To answer this question, let us have a look at the simplest communication between systems. The simplest form of communication between systems is the synchronous client-server communication, which we call point-to-point communication. This is when a client sends a request to the server and the server gives back a response. However, when more and more systems need to communicate between each other, point-to-point communication becomes very difficult to scale. This is because the systems become tightly coupled. One system, in order to send a message to the other, needs to know about the other, right? So system A needs to know about system B, and then system B needs to know about system C. This is really difficult to scale. That's why we say that with point-to-point communication, systems become tightly coupled. There are no delivery guarantees if one system goes offline. And also, the receiving system can be easily overwhelmed. This is because the receiving system does not control the pace at which new data comes to it, alright? It does not control that. So it can easily get overwhelmed. This is when Apache Kafka comes into play. Kafka acts as the middleman between these systems. It simplifies the communication by acting as the centralized communication hub in which these systems can send and receive data without knowing about each other. So as you can see in the diagram, Kafka is the communication hub, and we have these systems putting data into the communication hub and other systems extracting data from it. If we add a bit more details to this diagram, we will begin to see the different components between Kafka communication model. So as you can see, there is something called a producer, which we'll talk about very soon. So don't worry if you don't know what it is. There is something called a topic, and there is something called a consumer. And obviously, there is another thing called Kafka cluster, which contains the topics. It is important to mention over here that the Kafka topics are contained in something that we call a broker. And a broker is basically a Kafka server. Now let's talk about Kafka topics. Kafka topics are named streams of related data that are stored in the Kafka cluster. You can think of them as tables in database. However, they do not impose a particular schema, but rather store the raw bytes of data. What do I mean by topics store raw bytes of data? Imagine that I have this case class called person. You can think of the case class as a type, alright? Or as the shape of the thing that I want to store into Kafka. I create an instance of this person. Now, in order to store this person into Kafka, I need to convert this person into bytes. So, if I print these two things, as you can see, this is the person and this is the byte. So I store data into Kafka in this format as bytes. I hope this makes sense. Kafka topics are broken down into partitions. Each partition is an append-only log, and what this does is that it ensures that the data written to Kafka are in the same order in which they come in. So in short, Kafka topics are broken down into partitions, and partitions are the things that actually store the messages or events that we publish to Kafka. This is how I like to think about Kafka topics. I like to think about Kafka topics as containers that contains shelves. Each shelf, to me, is a partition, and each book on the shelf is basically a record. Now let's talk about Kafka clients. There are two basic Kafka clients, as we saw earlier. These are the producers and the consumers. Kafka also has some advanced client APIs, namely Kafka Connect for data integration and Kafka Streams for data processing. We will not be looking at these in this tutorial. Producers, what they mainly do is that they create new messages and the messages are directed to a specific topic. By default, the producer does not care what partition a specific message or record is written to. It will automatically balance the messages over all partitions of a topic evenly. In some cases, the producer will direct a message to a specific topic if a key is provided for that message. We will look at this in more details later. Consumers, on the other hand, are responsible for reading messages from Kafka. They also keep track of the messages that they've already consumed by keeping track of something that we call an offset in Kafka. The offset is a metadata, which is an integer value that Kafka adds to each message as it is produced. So when we produce a message to Kafka, inside of the Kafka cluster, Kafka automatically adds these offsets to the messages that we produce to Kafka before storing the message in a topic. So we saw that rather than having systems talk directly with each other, we could send a message to Kafka and anybody interested could read that message from Kafka, which means that we need a way to get the message or event or record, whatever you want to call it. We need to find a way to get the message from our systems to Kafka. To do this, we've already seen when we talked about the Kafka clients that we need something called a producer. So now let us see how the producer actually sends a message to Kafka. The producer sends a message to Kafka by creating something called a producer record. This producer record contains the name of the topic we want to send the record to and the actual value of the record. Okay, so we provide the producer record, the name of the topic, the actual value, the actual message that we want to actually send to Kafka or store into Kafka. Optionally, we can include the key and partition. The key is there so that messages with the same key will end up in the same partition. Now, when we send the record, the first thing that the producer does is that it will serialize the key and then the message or the value to byte array so that it can travel over the network. And we saw this earlier on when I created the person case class and transformed that into bytes. That is basically what the producer does internally. It takes the message and then it will serialize the message by converting it into byte array. And how does it do this? When we create a producer, we also give it a producer settings. And based on these settings, we provide a way to serialize the data into bytes. We will look at this later. Next, the data is sent to something called a partitioner. If we specified what partition the data should be sent to, the partitioner would do nothing and that data will go into that partition. If not, the partitioner will choose a partition for us and store the data in there. If the message is written successfully, we get back a record metadata. If not, the producer will try and try and try until it finally gives up. The number of times that the producer will retry can be configured. Okay? Usually, we do not care about the record metadata that is given back by the producer because everything that we publish to Kafka, we already have that information. That is basically how the Kafka producer sends message to Kafka. The Kafka Producer API has got a lot of configurations which you can use to configure how you want your producer to be. But one of the configurations that I would like to talk about is called ACKs or ACKs. This controls the number of partition replicas that a record must be written to before the producer considers the write as successful. When we create Kafka topics, we can specify a replication factor. The idea of Kafka is that we want to be highly available and we want to be fault tolerant. And basically, what the replication factor does is that it replicates our partitions across different buckets inside of the Kafka cluster. So a Kafka cluster is made up of lots of Kafka servers, all right? So imagine that we have 3 buckets on the cluster. So we have 3 Kafka servers and then we have a topic which has got 3 partitions and we have a replication factor of 2. What happens is that each partition will be replicated twice. So if you look at the broker 2, for instance, right? We have a leader partition. This leader partition is responsible for all the reads and writes from Kafka. So when we publish to Kafka, the message goes to this leader partition. When we want to read from Kafka, we'll read from this leader partition. So broker 2 contains leader partition 1. And on broker 3, we have a follower partition. What this follower partition does is that it basically copies data from the leader partition. All it has to do is that it has to keep in sync with the leader partition, just so that if something happens to broker 2 and the server is down, the replica will be elected as the leader and it will have all the data which was in the leader partition on broker 2. So again, just to recap, what replication factor is that we want to replicate our partitions across different brokers. A partition can either be a leader or a follower. A leader partition is responsible for all the reads and writes. A follower only has to keep in sync with the leader partition. This is because if the broker that the leader partition is on goes down, the follower can be promoted to be a leader so that we did not lose any data. Now let's go back to ACKs. We can have different types of ACKs. When we have an ACK of 0, it means that we want to publish a message to Kafka and forget. We don't care if the message is written to Kafka successfully or not. Most of the time, the message is written to Kafka successfully because Kafka is highly available. But we do not want to rely on this in production environments. So at least we set our ACKs to 1. What this means is that the message needs to be written successfully to the leader partition before the write is considered as successful. This is when we set the ACK to 1. When you set the ACKs to all, what this means is that you want all the sync replicas to receive the message before the message is considered as successful. That's basically it. That is basically what this configuration does. I hope this makes sense. Applications that need to read messages from Kafka will use a Kafka consumer to read messages from topics that the consumers are subscribed to. Now, Kafka consumers are normally in a consumer group. What is a consumer group? A consumer group is basically when a group of consumers come together to read messages from subsets of partitions. In this illustration, as we can see, there is a topic which has got 3 partitions and a consumer group that has got just 1 consumer. Since we only have 1 consumer, that consumer will be responsible for reading all the messages in all 3 partitions. But we can also have a consumer group which has got 2 consumers. And if we do have that, in this case, as you can see in the illustration, one of the consumer will be responsible for reading from 2 partitions and the other will be responsible for reading from just 1 partition. If we have the same number of partitions as consumers, then each consumer will be assigned 1 partition, as you can see in the image illustrated. If there are more consumers than partitions, some of the consumers will be idle. So it is not really wise to have more consumers than partitions. You can have more partitions than consumers because having lots of partitions is how topics are scaled. It is also important to note that you can have multiple consumer groups consuming from the same topic. I mentioned that in a consumer group, each consumer is responsible for consuming from a partition. But what happens if that consumer dies? When a consumer dies, it triggers something called a rebalance in Kafka. Basically, when consumers are pulling from a topic, so they are basically just on the background making requests to see if there are data in a topic. When they do that, they send a heartbeat to the broker called the group coordinator, and when they commit an offset, they also send a heartbeat. Committing an offset is basically when the consumer updates the position that it is in inside of the partition. So remember, consumers are responsible for consuming messages, and they consume the messages inside of the topics, and topics are made up of partitions. Now, when consumers consume messages, they need to update the position that they are in inside of the topic. Updating their position inside of the topic is called committing an offset. Okay, so when consumers make requests to topics, they send a heartbeat. When they update their position inside of the partition, they also send a heartbeat. Now, when this heartbeat stops, the consumer is considered as dead, and then a rebalance occurs. When a rebalance occurs, what happens is that the partition that this consumer was consuming is taken over by other consumers. So imagine that there are 3 consumers in a consumer group consuming from 3 partitions. So each consumer is consuming from 1 partition. If one of the consumer dies, one consumer will be responsible for consuming from 2 partitions, and then the last consumer will be responsible for consuming from 1 partition. This is basically what a rebalance is. It occurs when no heartbeat is received from the consumer by the group coordinator after a period of time, and this period of time is configurable. A rebalance also occurs when we scale our topic. Okay, so when we add more partitions to our topic. Why? This is because when we add more partitions to our topics, the consumers need to take into consideration those partitions, so they restructure themselves in order to consume those partitions. I do not want to go too much into details into the internals of Apache Kafka. If you want to know more about how rebalance and how the group coordinates and everything works, have a look at the Apache Kafka documentation. The last thing I would like to talk about is the schema registry. What is a schema? A schema is the structure of the data that we send to Kafka. An example of a schema is what you see on your screen. It is basically the shape of the data that we send to Kafka. Now, as far as Apache Kafka is concerned, we produce messages to Kafka. The messages are converted to bytes array and then sent to Kafka. So there is no way of verifying the shape of the messages that we send to Kafka. So we could send anything. Okay, we could publish anything to Kafka and the consumer will not be aware. Okay, so there is no data verification between the Kafka producers and consumers on the shape of the messages being sent to Kafka. This is where Schema Registry comes into play. The Schema Registry will handle the distribution of schemas to the producers and consumers. What do I mean by this? The producer, before sending a message to Kafka, will talk to the Schema Registry first and check if the schema is available. All right? If the schema is not available, the producer will basically register the schema and cache the schema in the Schema Registry. Once the producer does this, it will get that schema and it will use that schema to serialize the data that it wants to publish to Kafka. When it publishes the message to Kafka, inside of the message that it publishes, it stores the schema ID, so the schema that it's used to serialize the record or the message. When a consumer is consuming that message, the consumer will take that schema ID, it will go to the Schema Registry. Using that schema ID, it will get that schema and it will use that schema to deserialize that data. And deserialization basically means that the consumer will convert the bytes back into a normal type that we can then use inside of our application. This is what I mean by converting the bytes into something that we can use inside of our application. If you remember, at the beginning of this video, we created this person, all right? And we converted the person to bytes. Now, I'm going to convert the bytes back to a person. I've converted the bytes back to a person. That is what I mean by deserialization. So we take that bytes that we put into Kafka and then we convert that to a type that we can then use inside of our application. So in summary, a Schema Registry is there to basically help us to validate the schema or the shape of the messages that we send to Kafka. So the producer will send a message to Kafka. It will store inside of that message the schema ID. When we are consuming, we get that schema ID and we use that schema ID to retrieve the schema from the Schema Registry, and then we will use that schema to basically deserialize the bytes back into a form that we can understand and use in our other services. I hope this makes sense. I made mention at the beginning of this video that when we send a message to Kafka, the producer is responsible for serializing the data, so the key and the value of the data that we send to Kafka. And we are responsible for telling the producer how to serialize that data. And that is part of the producer settings. This, for instance, is how we do it in Scala. We provide a producer serialization key and a producer serialization value. It will be different in Python, it will be different in Node.js. But I just want you to know that we provide the serialization key and value, and then we tell the producer how to serialize the data before sending that data to Kafka. So in summary, we've had a look at what Apache Kafka is, we've had a look at what Kafka producers are, We've had a look at what Kafka consumers are, what partitions are, what topics are. We've learned a lot today. So that is all I would like to share with you guys for today. Thank you guys for watching, and I'll see you in the next video tutorial.